Hi class, in today's lesson we're going to talk about right triangle trigonometry, which is found in section 4.3 part 3. Our objective is to use trig functions to model and solve real life problems. Okay, so in example 7, solving a right triangle, it says a surveyor is standing 50 feet from the base of a large tree. The surveyor measures the angle of elevation to the top of the tree at 71.5 degrees. How tall is the tree? All right, so essentially what we have is we have a surveyor, and we're going to say that he's standing right here. This is the survey in blue. That's a person standing there. And he's 50 feet away from the tree. And they tell us that the angle of elevation, so from where he's standing to his view at the top of the tree, is 71.5 degrees. Okay, we can use that information to help us figure out the height of the tree. So if I re-sketch this information that I've been given, and that's not a great right triangle, but just go with it. We know that this side length down here is 50 feet. We don't know what y is, and we know that the angle here is 71.5 degrees. All right, so if we know this information, then technically, in regards to our angle that we were given, 71.5 degrees, then in reference to the angle, technically we were given opposite and adjacent, right? Opposite being the y and adjacent being 50 feet. So since we know something in regards to opposite and adjacent, then the only trig identity that refers to both of those is tangent. So we're going to use a tangent function to solve for y. So in other words, tangent of 71.5 degrees equals opposite over adjacent. Opposite is y, adjacent is 50, okay? So then to solve for y, we need to get rid of the fraction. So we're going to multiply both sides by 50. So we're going to multiply this side by 50, this side by 50. And in the end, y is going to equal 50 times tangent of 71.5 degrees. Again, you need to be sure that your calculator is set to degrees. The mode is in degrees. And so if you do that and you type this all into your calculator as is, you'll get y as about 149.43. And the measurement we were given was feet, so it's in feet. And we are done with example 7. All right, in example 8, it says a person is 200 yards from a river. Rather than walk directly into the river, the person walks 400 yards along a straight path to the river's edge. Find the acute angle between the path and the river's edge. Okay, so again, we're referring to some angle, and this angle here is theta. We don't know what it is yet. However, what we do know is this 200 yards and this 400 yards. Now, what will be helpful is if we understand the relationship between 400 and this angle theta. Since 400 is directly across from our right angle, then 400 yards is considered the hypotenuse, okay? And the angle and the side that's opposite, directly opposite of our angle, remember, is always called the opposite side. So opposite and hypotenuse, the only trig function, and when I say only, I'm talking about the basic version of it. The trig function that refers to opposite and hypotenuse is sine. So to find theta, we will use the trig function sine. So sine theta, because again, we have to use theta because we don't know what it is. So sine theta will equal opposite over hypotenuse. And again, that opposite side is 200 yards over the hypotenuse, which is 400. Okay, we know that reduces to 1/2. So in our calculator, to find theta, we will do the inverse of sine. So typically we use the inverse of sine button, or it looks like this. We use that button if we're trying to find the angle and we've been given the side lengths. So the inverse of sine of 1/2, typing it in as so into your calculator. Again, be sure that it's set to degrees. You will get 30 degrees. And that makes sense, right? Because one of the main facts that I've repeated over and over again is that sine of 30 is 1/2. So it's kind of like we said, well, sine of what angle is 1/2? That's essentially what we told the calculator. Sine of what angle is 1/2, and that what angle is 30 degrees. Okay, so the acute angle between the path and the river's edge is 30 degrees. All right, let's look at our last example. Okay, so in example 9, solving a right triangle, it says a skateboard ramp requires a rise of 1 foot for every 3 feet of horizontal length. Find the lengths of the sides B and C and find the measure of theta. Okay, so if it says that it requires 1 foot for every 3 feet of horizontal length, what that means is you have to think about it as a slope, right? Literally, it's a slope. So if we have rise over run, right, because we know slope is rise over run, and they're telling you that it must be 1 foot, which would be your rise, for every 3 feet of horizontal length, right? And what we've been given, our current rise, or your vertical length, is 4, and your current horizontal length is B, then if we solve this as a proportion, you would get B equal to 12. So that's the first piece of information. B is 12. Okay, now that we know that, then it would be helpful for us to also find C. C we can only find using Pythagorean theorem. So again, A squared plus B squared equals C squared. A we'll say is 12. B we'll say is 4. And C we don't know. So that's 144 plus 16 equal to C squared. That's going to give us 160 equal to C squared. And when we take the square root, we will get that C is approximately 12.65 feet. All right, so now that we know that, now then it's time for us to find the measure of theta. So if we want to find theta, it's best to go off of information and solid information, as much solid information or whole numbers that you can go off of. And so essentially what I'm saying is it's better to go off of our opposite side and our adjacent side, which then will tell us that we're talking about tangent. So tangent then, tan theta, which is opposite over adjacent, 4 over 12, or 1/3. To find the angle, we would use the inverse of tan with the ratio 1/3, or the side lengths of 1/3. So in other words, I'm asking the calculator, tangent of what angle gives you or has side lengths of 1 and 3. Okay, so tangent of what angle has side lengths of 1 and 3. If we put that in our calculator, we're going to get about 18.43 degrees. Okay, so we've answered both questions. Guys, if you have any questions, again, please be sure to come see me for tutoring.